All right, we're on the second page of Investigation B. For this page, we're going to be looking at all the triangles that form 45-degree reference angles. So let's look at step number 1, where it says find the points on the circle for all triangles with a 45-degree reference angle. Then make right triangles by connecting each point to the x-axis. Color the 4 triangles the same color. So step number 1 is to find the 4 angles that have 45-degree reference angles. Well, clearly 45 degrees is one of them. And let's also note that that's pi over 4 radians. I'm actually going to put a slash right here to show you that we're dealing with degrees or radians. The next place with a 45-degree reference angle is going to be that 135 degrees, also 3 pi over 4 radians. And next place is here. And that's going to be, well, this is 180. 45 degrees more than that is going to be 215 degrees. Sorry, 225 degrees. Also 5 pi over 4 radians. And the last angle, whose reference angle is 45 degrees, is here. It's going to be 45 degrees less than 360. So that'll be 315 degrees. Also 7 pi over 4 radians. Now, we want to get the coordinates of these 4 points. We want the coordinates of these 4 points. So to do that, the suggestion is to form triangles with each one of these. So I'm actually going to draw this triangle in right here. Now the important thing here is that this is the unit circle. So that means the hypotenuse length of that triangle is 1, because any radius of that circle measures 1 unit. So that hypotenuse of the circle is also 1 unit. So I'll put 45 degrees right here. Important thing to remember is that in a 45, 45, 90 triangle, if we want to go from the longer length side, which in this case is longer length side is 1, to get to the shorter side, we need to divide by rad 2. And so that gives us 1 over rad 2 units for the shorter leg. But we got to rationalize that. And to do that, we multiply by rad 2 over rad 2, which gives us the result of multiplying numerators together. 1 times rad 2 is rad 2. Rad 2 times rad 2 is rad 4, or 2. So both of these legs measure rad 2 over 2 units long. Let me write that a little more clearly. Rad 2 divided by 2 units long. Well, that tells us that we actually go rad 2 over 2 units to the right, and we actually go rad 2 over 2 units up. And again, we're talking about this triangle right here. So we're talking about this triangle right here. Okay. And so by writing the side lengths of that triangle, we actually now have the coordinates of this point right here. So the coordinates of that point are going to be, well, we went rad 2 over 2 units to the right, so that's our x coordinate right here. And we went rad 2 over 2 units upward, and so that's our y coordinate. Okay, and that makes sense because a 45, 45, 90 triangle has 2 congruent legs. And so therefore the x coordinate and the y coordinate are the same. That's really helpful because we're going to do the same thing in other quadrants. We're going to draw a right triangle here, making that a right angle. And then now that we have we're dealing with another right triangle right here, And we can shade that in. And we're also going to look to find the lengths of the two legs, because the leg lengths will give us the coordinates of this point right here. So we're trying to get the x and y coordinates of that point. Well, again, the reference angle is 45 degrees. So that's a 45-degree angle right there. Write that a little more clearly. And so we know the legs of the 45, 45, 90 because the hypotenuse is 1. And the legs are going to be rad 2 over 2 units to the left, which importantly makes that a negative since we're moving to the left. And we're going up rad 2 over 2 units. So that's going to be a positive value. Well, again, this is our x-coordinate because we went to the left rad 2 over 2 units. So that's why it's negative. And we went up rad 2 over 2 units. So that makes our y-coordinate positive rad 2 over 2. Well, that gave us the coordinates of the point that corresponds with 3 pi over 4. Well, let's do a similar thing here. You're going to start to see a pattern because if you look at these coordinates right here, they're the same, except maybe the coordinates will be positive or negative. So we just need to kind of pay attention to the quadrant we're dealing with. All right, so for this next angle, which corresponds with 5 pi over 4 or 225 degrees, we want to form a right triangle. We always draw the segment up to the x-axis, and the reference angle here is 45 degrees. I'm going to erase this big circle right here. And now we're talking about this triangle right here. So we want to find the legs of this triangle so that we can label the coordinates of this point right here. Okay, and again, we know the hypotenuse's length is 1, and we already know this coordinate because this side is the same for both triangles. So that's negative rad 2 over 2. So we already know the x-coordinate of this point. It's negative rad 2 over 2. Again, that's how far we went to the left to get to the pink point, and we go down rad 2 over 2 units because we're going down from the x-axis. Well, that makes our y-coordinate negative rad 2 over 2. All right, well, the same thing's going to happen in the fourth quadrant. So again, we draw a leg to the x-axis, draw the hypotenuse in there. Our hypotenuse's length is 1. We're dealing with this triangle right here. And we're just trying to write the coordinates for this point right here. Well, we already have the x-coordinate because we went to the right rad 2 over 2 to get to the pink point. So our x-coordinate is positive rad 2 over 2. That's this number right here. And then it's a 45, 45, 90 triangle. So both legs are the same. But this time we're going down rad 2 over 2 units to get to this point right here. So that means that our y-coordinate will be negative rad 2 over 2. Again, that's that number. Well, that completes the coordinates for all reference angles that have pi over 4. So we'll use that to solve problems below. Thanks for watching.